In this video, I'm going to talk about how to find the quotient and the remainder of a polynomial function by using long division method. When a polynomial is divided by a divisor, under the symbol of the division, inside here, that is polynomial. And on the right hand side here, this is divisor. And the result on top here is quotient. Then the number under here is remainder. So when we carry out the division by using this method, this is called long division method. Based on the result of the long division method, now we can write down that the polynomial is equal to the divisor multiplied with the quotient and plus the remainder. When finding the quotient and remainder of a polynomial, actually the result depends on the divisor. If the divisor is a linear divisor, then the remainder is a constant. And at the same time, if the polynomial is in degree of n, that is, the highest power of the polynomial is n, and when the divisor is a linear, then the quotient is in degree n minus 1. That is, the highest power of the quotient is n minus 1. If we write this equation in mathematical symbol, so you can see that when the polynomial, the highest power of the polynomial is n, and when the divisor is linear, then the remainder is a constant. And the quotient, the highest power of the quotient is n minus 1. So when we sum the highest power of the divisor and the quotient, so we find that it is same as the degree of the polynomial. Similarly, if the divisor is a quadratic, then the remainder is a linear. And if the polynomial is in degree of n, and if the divisor is a quadratic divisor, then the quotient will be reduced, the degree becomes n minus 2. And the remainder is a linear. And when we write this equation in mathematical symbol, then we can see that polynomial in degree of n, and when the divisor is a quadratic, then the remainder is a linear. Then the degree of the quotient will reduce, becomes n minus 2. When we sum the highest power of the x between the divisor and the quotient, so we find that the sum of the power of x is same as the polynomial. Now let's try this question. The polynomial here is divided by x minus 1 and state the quotient and the remainder. So now we are going to use the long division. We start from the symbol of the division. So outside here, we write the divisor x minus 1, and inside here, we write down the polynomial. When doing long division involving polynomial, one of the important thing is the power of the term. The power of the term should be in the descending order. So when the first term power 4, then the second term should be power 3. So notice here, we don't have the x power 3. If we don't have the x power 3, now we should replace the x power 3 with the coefficient 0. That is 0x power 3. So now the power of x is in the descending order. So now we can start doing the division. we start from the first term of the divisor and the first term of the polynomial. And each term consists of the coefficient and x. So we will do one by one. So now we start from the x. And we know that the divisor multiply the quotient, then we will get the polynomial. Since the first term x is power 4, and the first term of the divisor is x power 1, so we should think that x power 1 multiply what? We will get x power 4. So sure, we know that must be x power 3. So x power 3 times x, we will get x power 4. And followed by the coefficient. So the divisor, the coefficient is 1. And we must think that 1 multiply what number in order to get the coefficient 2 here. So definitely is 1 multiply with 2 in order to get the coefficient 2, so that we will get the first term 2x power 4. So once we have got the first term for the quotient, that is 2x power 3, and we will continue to do the division, that is 2x power 3 multiply with this minus 1, then we will get negative 2x power 3. Then we are going to minus, that is 2x power 4 minus 2x power 4, then it is equal to 0. Then for 0 minus negative 2, because this is minus, this is negative, so minus negative, that is equal to positive. So we get positive 2x power 3 here. Now before we can continue, we should pull down the following term, that is 3x power 2. Now we are going to repeat the same step as just now. So now we look at the first term, 2x power 3. So first we should get x power 3 here, and the divisor is x. So we should think x multiply what? Then we can get x power 3. So sure, it is x multiply with x power 2, we will get x power 3. Now the coefficient. So the coefficient, we should get a 2 here. Since the coefficient of the divisor here is 1, then we should think that 1 times what number to get 2. So definitely is 1 times positive 2 to get the 2. We must consider the positive and negative here. So since this one is positive, so this is plus 2, that is positive 2. So 2x power 2 times x, we get 2x power 3. Once we have got the terms at the quotient here, now we can continue the following, that is 2x power 2 times negative 1, then we will get negative 2x. Now we minus these two expressions, so 2x power 3 minus 2x power 3, we will get 0. Then 3x power 2. When doing this one, you have to be very careful because this is the minus, this is the negative 2. So we should consider 3x power 2 minus negative 2x power 2. Negative and minus will become positive. So we'll get 3 plus 2. So 3 plus 2 is equal to 5. So 5x power 2. And before continue, we should bring down another term, that is minus 5x. Then we repeat the same step. Now I'm going to find 5x power 2 since the divisor is x. So x definitely times x, we will get x power 2. Then as the coefficient 5 here, since this is 1, so 1 times positive 5, we should get 5. So means 5x times x, we get 5x power 2. Then by using this term, we continue multiply negative 1. So 5x minus 1, then we will get minus 5x. Then we minus 5x power 2 minus 5x power 2, that is 0. Now for this one, negative 5x minus negative 5x. Since negative and negative becomes positive, so negative 5 plus 5, then we will get 0x. Now we proceed to the final step, that if we pull down the plus 7 and we repeat the same process. So this one, x times what? We get 0x, definitely is 0. So 0 times x, 0x. 0 times negative 1, 0. So therefore, finally, when minus, we will get 7. Okay, so now we have already finished the long division. Now the question, state the quotient and the remainder. So from the long division, this is the quotient. So now, therefore, the quotient is 2x power 3 plus 2x power 2 plus 5x. We ignore the 0 behind here. Then for remainder, this is the remainder. So remainder is equal to 7. And then the question asks, write the polynomial in the form, this one. So this is polynomial. This is, one is divisor, one is quotient, and this one is the remainder. So based on the long division, okay, polynomial is this one. So we write down the polynomial equals, then this is divisor. So divisor is x minus 1. And this is quotient. Quotient is what we get from the long division here, plus the remainder. The remainder is plus 7. So finally, we will get the answer for this question. Now, based on the result here, we can double check what we have learned just now. That is, when the divisor is a linear, the remainder is a constant. And at the same time, when the divisor is linear, then the highest power of the quotient is n minus 1. So since the polynomial, the highest power is 4, so the quotient, the highest power becomes 3. That is 4 minus 1. Then the sum of the highest power between the quotient and the divisor, 3 plus 1, it is 4. So same as the highest power of the polynomial. Now let's try next example. The polynomial here is divided by 2x plus 3. State the quotient and the remainder. So we start from the symbol of the division. And outside here, we write down the divisor 2x plus 3. And inside here, we write down the polynomial. So first, we double check whether the power of x is in the descending order. So it is in the descending order. So now we can start. Okay, first we are going to divide the first term. The first term is 3x power 3, and the divisor, the first term is 2x. So we start from the x. So we have to think x times what? We get x power 3. So definitely is x times x power 2, we get x power 3. Now for the coefficient, so we have to think 2 times what? We get 3. So we know that 2 times 1 is 2. 2 times 2 is 4. We are not able to get 3. So what we should do? So now we should do some calculation. That is, we should think that 2 times what in order to get 3. So now when we shift the 2 to the right hand side, so we find that this value should be 3 over 2. So this value should be 3 over 2. So now we continue. 3 over 2 times 2 is equal to 3. And after we have got the first term, in the quotient, now we can continue for the following, that is 3 over 2x power 2 times 3. Then by pressing the calculator, we find that it is equal to 9 over 2x power 2. So now we minus. So 3x power 3 minus 3x power 3 is 0. Then for this one, negative 9 minus 9 over 2. So by pressing the calculator, we find that the value is negative 27 over 2. And before we proceed, we need to put down the next term, that is minus 4x. Now we repeat the same step as just now. Okay, for the x first. So we consider x times what to get x power 2. So definitely it is x times x. We get x power 2. Now for this one, okay, in order to get negative 27 over 2, so we should think 2 times what to get negative 27 over 2. So when we shift the 2 to the right hand side, so actually this number is negative 27 over 4. So now we know that it is negative 27 over 4. Then we continue here. So negative 27 over 4 times 2 is equal to negative 27 over 2. Then continue with this one 3. Negative 27 over 4x times 3. It is equal to negative 81 over 4x. So when we minus, this x power 2 will finish, becomes 0. And for this one, by pressing the calculator, negative 4 minus negative 81 over 4, then we get 65 over 4. Then we continue, put down the 5. So now we repeat the same step. So since this last number, it is a constant, so we should think that 2 times what number, we get 65 over 4. So shift the 2 over right hand side, then actually that is 65 over 8. So this is 65 over 8. Now we continue. 65 over 8 times 2, then we get 65 over 4. And 65 over 8 times 3, then we get 195 over 8. Then we minus, so this one x will become 0. Then 5 minus 159 over 8. By pressing the calculator, then we get negative 155 over 8. So now we have finished the long division. So from the result, the quotient is this one. So therefore, this is the quotient. Then for the remainder, based on the calculation, the remainder is negative 155 over 8. And write the polynomial in this form. So we start from the polynomial. The polynomial is this one, equal to the divisor. Divisor is 2x plus 3. Then multiply with the quotient. Then this is the quotient. And plus the remainder. So the remainder is negative 155 over 8. And after this, we can combine this quotient becomes one single term. And when we factorize the 1 over 8 out here, then we will get the answer like this. Now based on this result, once again we can double check. When the divisor is a linear, then the remainder is a constant. And when the divisor is a linear, then the highest power of the quotient is n minus 1. That is, n is 3, so 3 minus 1, so the highest power of the quotient is 2. Now we try this question. The polynomial is divided by x plus 1, x minus 1. State the quotient and the remainder. So we start from the symbol of the division. For the divisor, this is x plus 1 times x minus 1. So when we write the divisor here, we should expand this expression. So when we expand, this one becomes x power 2 minus 1. So we find that now the divisor is a quadratic divisor. And the polynomial is this one. So notice that we don't have x power 2 in the polynomial. So we must replace 0x power 2 here in order to get the power of the x in descending order. So now we start. So first one, we take the first term, x power 2. We know that x power 2 times x power 2, we get x power 4. Then using this x power 2, we continue x power 2 times negative 1, we will get negative x power 2. So since negative x power 2, we should write at the same column at the x power 2 here, so that when later on when we do the minus, it is not confusing. So now when we minus x power 4 minus x power 4, it is equal to 0. So for this x power 3, negative 9x power 3 minus 0, then we get negative 9x power 3. For this one, 0 minus negative. So negative becomes positive. Then we get positive x power 2. Then before we continue, we put down the following term. Then we repeat the same step. So for x power 2, we know that x power 2 times x, we will get x power 3. As the coefficient, this is 1. And we should get negative 9. So therefore, 1 times negative 9, we get negative 9. So using this term, we continue. Negative 9x times negative 1, we will get positive 9x. So positive 9x, we should write down at the same column that is x here. So when we divide, this one will become 0. So x power 2 minus 0, we get x power 2, and negative 4 minus positive 9, so negative positive, that is negative, so negative 4, negative 9, we will get negative 13x. Then plus we put down the 15. So for this one, x power 2 definitely is plus 1, so x power 2 times positive 1, we get x power 2. So 1 times negative 1, we get negative 1. So when we minus x power 2, it becomes 0. So negative 13x minus 0, negative 13x. 15 minus negative 1, negative becomes positive. So becomes plus 16. So after finish the long division, now we are going to write down the quotient. So based on the result, this is the quotient, and the remainder is at the below here, that is negative 13x plus 16. Then write the polynomial in this form. So we start from the polynomial equals the divisor. Now divisor we should write back in the factor form. That is x plus 1, x minus 1, then the quotient, then followed by the remainder. So now this is the result of the long division. And once again, we can double check. That is, when the divisor is a quadratic divisor, then the remainder is a linear remainder. And for the quotient, the degree of the quotient is n minus 2. So n is 4, minus 2 is 2. So that the degree of the quotient is 2. I think that's all for now. If you feel that this video is beneficial, so please give me a like. Thanks for watching.